Thank you very much. So I'm Everest Çorbaxhi, and my thesis dissertation is City Information Modeling as Vital Digital Twin for Improving Sustainability. So I have developed it in 5 main topics. So without losing time, I'm starting. Smart cities, urban infrastructure, management and governance implications. There are many implications. There are many implications on a systemic view of cities, which of primary importance is management and governance. The city and its infrastructure are social technical systems that interact, generating feedback loops on both sides. How these layers of technical and social dimensions are layered affects how people work, whether they have access to essential services. All of this directly affects how the city performs, how resilient, efficient, and sustainable it is. Implications of digitalization on industries and infrastructure. Digitalization can disrupt any activity with a value chain, but some are more vulnerable than others. Many industries can benefit and be affected by this potential of mirroring digital information. Infrastructure and services are connected by an in-between digital layer, which connects customers and infrastructure provided services. This digital layer can obtain smarter energy, transportation, waste management, and other city features. Smart urban energy systems. The aim to reduce CO2 emissions and become more energy self-sufficient is one of the most crucial objectives of urban energy systems. Digitalization is the necessity in which the urban energy system can become smart. The economic and social dimension is also considered connection to the liberalization of electricity markets. Smart grids for cities. A range of tools that provide sensing is needed for developing smart grids. Operators need to be able to measure the exact status of assets and get quasi-real-time valuation results. There is a need to adopt mechanisms to achieve synchronization. Smart grids power systems are dependable on the institutional, regulational, and managerial perspective. Energy system data layer. Smart urban energy services providers are the issue of regulating competition and ownership without having monopoly tendencies or market distortion. Data are generated from 3 main sources: user behavior, the grid's behavior, and available electricity or energy produced behavior. These data are considered as a function of user and generator behavior. IoT system architecture. Software architecture and application architecture that satisfies specific software requirements are built through different techniques: design, evaluation, and validation of whether the design architecture is relevant through smart IoT, and artificial intelligence systems are needed for software architecture and application architecture. Architecture importance in IoT system development. In many software systems, requirements are first analyzed and many functional requirements are converted into use cases. Use cases are applied in combination of input and corresponding outputs from the user viewpoint. A typical analysis design method analyzes interactions among elements, realizing functionality for each use case. It can be challenging to build a relation of components between requirements, models, and traceability. Architecture drivers. The architect is the person who designs architecture. He determines the growth structure and behaviors of a system using coarse-grained modules. Requirements are analyzed according to business processes and actual goals. When handling quality such as performance, availability, modifiability, and testability. The last concerns are decisions on necessary design, regardless of the requirements and goals explicitly stated. Layers pattern. Pattern-oriented software architectures patterns are straightforward, classic, and generally used in various places. The concept of the layers architecture pattern is to express an entire system with accumulated layers of coarse-grained modules. When a change is made, a particular module is modified, and the other modules that use that module are also affected. Pipes and filters pattern. Pipes and filters pattern is a pattern to process source input. It puts obtained results in another process and then the obtained results in another process again. It enhances reusability for each filter component, and the data processing method can easily be changed according to the need. This makes data processing connections more flexible. Microsoft Azure IoT reference architecture. Microsoft has developed a more refined architecture as IoT edge devices. The basic concept for IoT system is based on three main components: things, insights, and actions. In things subsystems, there are IoT devices that are connected to cloud gateway, which works as an IoT hub. Other components connect mapping to associate with specific services. Big Cloud T. An IoT platform is a set of devices, applications, and legacy data sets that can be connected to one another. These components can be accessed by standardized API to process data, obtain results using machine learning modules, and analyze big data according to need. Big Cloud T is an example of a reference architecture used by various organizations and participants. GIS. GIS software, the Internet of Things, implies acts of spatial curing no longer restricted to professionals. Web mapping allows non-professionals to perform analysis of geographical information through applications such as Google Maps and Google Earth. GIS is more than just a software installed onto a machine. It is designed to organize, analyze, and classify data to another user's queries. Spatial data and analysis. In GIS, data is exchanged between different projection systems, making measurements and approximity analysis on features. Two basic and common functions are overlay and buffer. The overlay is to visualize and quantify the spatial relationships between different themes of the same area. Buffer means creating a surrounding area around a point, line, or area feature. Mapping process. Spatial and locational data can be collected through terrestrial and GPS surveying. There are positions and coordinates for objects, and points of interest are collected and compiled. Attribute data is concerned with the characteristic of an object and point of interest, example, build and land use, population, etc., and can be compiled through documents such as building plans. ArcGIS Pro, creating feature class and entering data. After positioning the map in the desired location, several applications can be performed through GIS Pro software. It is possible to create and digitize roads, building shapes, and enter as well as calculate various informations in the attribute database chart. Different feature class layers can be created to enable different performance analysis through this gathered data. Sustainability. Sustainability efficiency assessment. The expansion of urban settings is linked to global sustainability concerns, particularly in places where the urbanization process is still developing, or the urban metabolism is expressing excessive regeneration. Existing building certifications are the most acknowledged method of linking sustainability to greenhouse gas emissions from a life cycle assessment standpoint. District energy. The most of the energy buildings use is for heating and cooling, and most of this comes from fossil fuels. Sustainable cooling can be achieved by heating homes with underground heat or using cold water from rivers to cool whole neighborhoods. A district network energy system comprises underground insulated pipes that distribute hot or cold water to multiple buildings throughout a district, neighborhood, or a city. District energy systems can use far large sources of heating and cooling. These sources include waste heat from industry or power stations, solar thermal, groundwater, and sewage, and free cooling from lakes, rivers, or seas. Building integrated modeling. Building information modeling is an open approach to building integrated modeling through different software. BIM can provide a different alternative for architectural solutions to provide analysis for them and elaborate plans that will be used within the city. Database engineers have important roles in linking different parameters to the buildings and implementing connectors to different providers. 3D models can include surface implementation of the building, the texture appearance of infrastructure. All these possibilities are optional or desirable for performing the maintenance. Different analysis can be performed related to surfaces, orientation, or even structural ones. Solutions for performing automatization or different kinds of materials can be included. Crossing information between building models makes it easy to perform analysis or produce new data and deliver digital reports on that regard. Digital reports and documents can be delivered or shared with contractors, subcontractors, and other entities. This makes the overall picture of a holistic analysis and a sustainable life cycle assessment. Digital twin at the city scale. Warrington Borough use case, ICL, digital twin of the Northwest project. Digital twin project targets the entire system cost and carbon reduction of the locality of the Warrington Borough. It also intends to assess and understand the social impact and potential benefit from this cost and carbon emission reduction. The project is focused on an area about 182 square kilometers located in Northwest England with a total population of 210,000 and 90,000 buildings. It aims to create a 3D model of buildings and assessing energy consumption for each. ICL, Intelligent Communities Lifecycle Tools. ICD, Intelligent Cloud Data, is a master planning and urban design tool used to create models and populate the data into the models. VE, Virtual Environment, is an energy simulation tool used on buildings. IVN allows to perform energy and carbon analysis at a larger scale, at community scale, station scale, etc. iSeam, an online collaboration platform, is also the platform hosting the final digital twin of the borough. The first task for creating the model was splitting it into 29 submodels in the ICD, which allows gathering within a single platform. The model was divided into coherent urban areas and with a limited number of objects. Each model is synchronized within the same iSeam online platform, batching all these models and data all together to create a digital twin. After creating the models, the first step is identifying the data and populating with relevant information. The EPC, Energy Performance Certificate database, is obtained and used as a CSV file for construction date and building characteristics. The electrical network data is provided by the local network distribution operator with a geographical file as well.
You've got 30 seconds to finish, please.
Okay, I'm finishing. All these were imported into processes, GIS file import and CSV file import. Building use. Data provided by the City Council was imported as a CSV file and then converted into the ICD from a previous use classification to the primary use. Once the conversion work is done, the data are imported and incorporated in the digital twin that ensures each property is assigned correctly with the reference matching key. Okay, I'm going to the last topic that creates the simulation. So all these buildings that are populated with data from the local council of the city. At the end, the aim is to create the simulation and to put the local district with an archetype with 5 types of archetypes that are created, and to make the simulation for further needs, whether the envelopes or performance envelopes of the building will be changed and the simulations will be developed. So if I'm on time, I'm shorting this out from here. Okay, is that all right?
Yeah, we are 1.5 minutes over time, so
2 minutes, okay. So I'm sorry I couldn't manage time.
Yeah.
The last. I'm moving the slides, by the way, so everyone could see the slides. So that's it. Thank you.